Hi, this is Ms. Hornell. Please have out your calculator and your periodic table. Today we're going to talk about empirical formulas and molecular formulas. So the molecular formula for a compound is its true formula. It's actually what the ratio of its elements are as it exists in nature. The empirical formula for a compound is always its reduced version. It's in its simplest formula. Sometimes the empirical and the molecular formulas are identical. So if you look at the molecular formula of hydrogen peroxide, it's H2O2. That's its actual formula as it appears. But the empirical is the reduced form, is HO, because the 2 is reduced down to H and O, simplest ratio. Carbon dioxide is CO2. That's its molecular formula. Its empirical formula happens to be the same, CO2, because 1 and 2 will not reduce any further. Butane is actually C4H10. That's what it is actually. The empirical formula is its reduced form. So what number will go into 4 and 10? It will be 2, so it will be C2H5. Iron 2 oxide is FeO. That's the molecular formula. And the empirical formula happens to be the same, FeO. You can find the empirical formula for a compound if you know its masses or its mass percentages. So these are the steps that we would use. The first thing you want to do is make sure you have the mass, or if you're given percentages, if you assume that you have a 100-gram sample, then your percentages will become your masses. You're going to convert the masses to moles using your molar masses, and then you're going to compare the mole amounts by dividing by the smallest. This will usually give you a whole number ratio, which are the numbers of the elements in the empirical formula. But if you don't get a whole number, then you're going to have to multiply the numbers by some positive integer until they are all whole numbers. So for example, if you do your mole, you divide by your smallest and you end up with something that ends with 0.9, it's okay to round that up to the nearest whole number. If it ends in 0.1, you can round that down. However, if it ends up being 0.5, you can't round that up and you can't round that down. So what you would do, is multiply that by 2. If the ending is 0.33, you can't round that up, you can't round that down. You multiply that by 3 and it gets you to a small whole number. If the ending is 0.66, you can multiply that by 3. That will also get you to a small whole number. And if it's 0.25, you can multiply that by 4, and that would get you to a small whole number as well. All right, oops. And then you will write the empirical formula. All right, so let's work some of these. It says find the empirical formula for a compound that's 5.9% hydrogen and 94.10% sulfur. So since they give us percentages, if we assume we have 100 grams, 5.90% of 100 grams is simply 5.9 grams. So we would take that percent and just make it into grams, and the same thing for 94.10. What you have to do next is convert to moles. All right, and since we've done this in previous videos, I just went ahead and preset this for you. You should know how to take grams and convert it to moles, and grams and convert it to moles. So this is the moles of hydrogen and the moles of sulfur. The new thing is once you've converted to moles, you have to divide by the smallest one, which happens to be this number here. And what you do to one, you do to them all. And what you're going to get here is you're going to get this is equal to 2. And this is equal to 1, and that is small whole number ratios. So how many hydrogens do we have? 2. And how many sulfurs do we have? 1. And so this would be the empirical formula, hydrosulfuric acid. What is the empirical formula for a compound that is 25.9% nitrogen and 74.10% oxygen? First thing you want to do is convert to moles. You want to get to moles. And since we've done this so many times, I went ahead and preset this. So grams to moles, grams of oxygen to moles of oxygen. Now that we're in moles, then we're going to divide by the smallest moles. So that would be, in this case, 1.8487, that equals 1. And then 1.8487, and that is equal to 2.5. You can't put 2.5 as a subscript, and it will not round up, and it will not round down. So since it ends in 0.5, you'll multiply it by 2. So that will give you 5 And then what you do to one, you have to do to the other. So how many nitrogens do we have? We have 2 nitrogens. How many oxygens do we have? We have 5. So that ends up being dinitrogen pentaoxide. The next one says a 25-gram sample of a compound contains 6.64 grams of potassium, 8.84 grams of chromium, 9.52 grams of oxygen. Find its empirical formula. So you're going to convert to moles. You did here. Since we've done this so many times, I went ahead and set it up for you. You can see that we've converted. You would have to show all of your work. And then what you're going to do is divide by the smallest moles. The smallest moles in this case looks to be here, 0.1698. That is 1. 0.698, 1, and 0.1698. And that is going to be equal to 3.5. That cannot be a subscript, and it will not round up, it will not round down. We multiply that by 2, we end up with 7. And what we do to 1, we do to them all. So we end up with K2Cr2O7, and hopefully you recognize that as potassium dichromate. Now, how are we going to find the molecular formula? That was how to do the empirical. Well, for the molecular, you first have to make sure you have the empirical formula. If you don't have it, you're going to have to calculate it, and that's what I just showed you how to do. And then you'd have to find the mass of the empirical formula, the molar mass of the empirical formula. And then what you're going to do is you're going to divide the molar mass of the molecular formula by the molar mass of the empirical, and that should give you a whole number. If it does not, you've done something incorrectly. Now, when you get that whole number, that's just the ratio. So then what you're going to do is multiply the empirical formula subscripts by that whole number. All right, so let's get busy on this. This says find the molecular formula for a compound with an empirical formula of CH2 and the molar mass of 84 grams per mole. So we know this is the molar mass of the molecular compound. We need to find the molar mass of the empirical. And since we've done this so much, I went ahead and calculated it out for you. And so we're going to divide that. And this should be a nice whole number ratio. 84 divided by 14.04 is 6. 6 isn't your answer. Your answer is going to be a molecular formula. So what you do is take that 6 and you multiply it to all the subscripts of your empirical. So that's going to be C6H12. And that would be your molecular formula. Find the molecular formula for a compound with an empirical formula of CH2O, and the molar mass is 90. So we know the molar mass, and we're going to have to divide it by the empirical mass of this. So I'll reveal if you need to review how to calculate molar mass, but it's going to be 30.03. And so when you do 90 divided by 30.03, you get 3. That's not your answer. You have to multiply it to your subscripts and end up with C3H6O3. That is your answer. Now we're going to connect the two. So this one says, what is the molecular formula for a compound that is 40% carbon, 6.6% hydrogen, and 53.4% oxygen? So in this case, they don't give you the empirical formula. So guess what you're first going to have to do is find the empirical formula. And that's what I showed you to do earlier in the video. So since we've been doing that, you're going to convert to moles. Okay. All right, and so we're going to divide by the smallest. All right, and that's going to be 1, that's going to be 1, and then this one's going to be 2. So the empirical formula is 1 carbon, 2 hydrogen, and 1 oxygen. Okay. Now we actually calculated this on the previous screen. So this is the empirical formula, and we know its molar mass is 30.03. So what we'll do is we'll take the molecular mass, 120, divide it by the empirical mass, which is 30.03. And when we do that, you get like 3.99, which is 4. But that's not the answer. You got to take that 4 and multiply it to all those subscripts. So it's C4H8O4. This is the longest one you would get because you had to do the empirical first, then find its molar mass, then do the division, and then get your molecular. All right, take a moment, pause the video, and try to work this one. All right, let's see how you did. So we converted to moles. Move this up a little bit for you to see. So we converted to moles here, 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 here. Then we divided by the smallest here, 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 here. That gave us our subscripts here. And then what we had to do was calculate the empirical mass. And so then we took the molecular molar mass that was in the problem and divided it by the empirical mass to get 2. Of course, that's not the answer. So then we have to take that 2 and multiply it. So each one of those, and this is your molecular formula. I hope you took good notes, have good examples. Come to class with any questions you may have.